We're going to be getting into some polynomial graphs today with 6.2. And we're going to start out with what are called parent functions. This refers just to the original shape of the graph before it has any kind of transformations at all. So before it's been shifted, stretched, or anything like that. So the first one is a constant, and we talked about a constant. The degree is 0, meaning there's no x at all. So we just say y equals c. It's just some number. So y equals 7. Y equals -10. That's a constant. And that is just a straight horizontal line. And it crosses the y-axis at whatever that number is. In this case, it's c. A linear graph, we talked about, had a degree of 1. So the original one is y equals x. And that is this line right here. It's just a straight line. It's linear. Quadratic is y equals x squared. You should have an idea of what this graph looks like. So we did this in Unit 5. That's called a parabola. Y equals x cubed. That's a cubic function. So the parent function, if you were to type in just x cubed, Miss Johnson. Yes, I will. So if you were to type in y equals x cubed, it's going to look like this. However, most of the graphs you see will look more like this that I'm doing in orange. A quartic graph is y equals x to the what? 4th. The parent function, meaning just the original x to the 4th with nothing else added onto it, looks a whole lot like the quadratic. So just a little bit wider. But most of the time you'll see it look like this. Something like that. Or upside. I probably should have done it upside down, actually. This right here would be y equals negative x to the 4th with something added onto it at the end because it's upside down. And then a quintic is y equals x to the 5th, and The parent function looks a whole lot like the cubic. But you'll see it more like this. 1, 2, 3, 4, 5. Generally, it's going to cross 5 times the x-axis. A quartic could cross 4 times. Cubic, 3 times. So the first big thing with these graphs is identifying the end behavior, which is which direction the arrows are pointing. And there's 2 ways to tell. Now you could just type it into the calculator and look at the direction it's going, but just by looking at the equation, you can tell the end behavior. So we look at the leading coefficient. The leading coefficient is the number in the front. So we're looking at the number in the front and whether that's positive or negative. And then we also look at the degree and determine if it's even or odd. And that tells us our end behavior. So if we have a positive leading coefficient and the degree is even, so like x squared, x to the 4th, x to the 6th, then both sides point up. We would say it rises to the left. If it goes up, it rises. If it goes down, it falls. So this rises left, rises right. If it's a positive leading coefficient, but it's an odd degree, looks like this. So it falls left, rises right. A negative leading coefficient and an even degree, they both fall. Falls left, falls right. And a negative leading coefficient and an odd degree, rises left, falls right. And you technically don't have to have this memorized if you have your calculator and you can type in the equation. You could just look to see if it's going down on the left or up on the left. So I am going to kind of rewrite this chart really quick. We have a positive leading coefficient, negative leading coefficient, even degree, odd degree. And this was up, down, down. I'm just recopying that chart really quick so you don't have to flip back and forth. This is positive leading coefficient, negative leading coefficient. That should be enough. Negative leading coefficient, and then even degree, odd degree. So number 1, my leading coefficient, this is the number in the front, is that positive or negative? It's positive. And then is my degree even or odd? Even. So positive, even, they both would point up, meaning it would rises to the left, rises to the right. If you wanted to type it in, it just might take you a little longer. 4x to the fourth plus 6x cubed minus x. If I look at the graph, notice the left and the right are both going up. The arrows point up if I were drawing arrows on the endpoints. Okay. Number 2, is my leading coefficient positive or negative? Negative. Is my degree even or odd? Even. Your highest exponent is 2. Your highest exponent is 2, so it's even, so they both point down. Falls to the left, falls to the right. Number 3, leading coefficient, number in front, positive or negative? Positive. Degree, odd. It's a 3. So it would be this one. Positive, odd. Falls to the left, rises to the right. So notice the left, the arrow would point down here, and the right side, it would point up. Number 4, leading coefficient, positive or negative? Negative. Degree, even or odd? Odd. So rises to the left, falls to the right. Fill in the blanks on numbers 5 and 6. Number 5, you should have falls to the left, falls to the right. And number 6, falls to the left, rises to the right. Number 7 and 8, I'm giving you a graph, and you need to tell what the leading coefficient is and the degree. So here we have 2 arrows that point down. So if we look at our chart, that is a negative leading coefficient and an even degree. So I was looking, these arrows both point down, so negative and even degree. What would the leading coefficient be on number 8, positive or negative? Positive. And the degree is odd. Good. Any questions on that? All right, turning points. A turning point is where the polynomial changes direction. If this turning point is higher, so it's a single point, if it's higher than anything kind of around it, it's called a relative maximum. And if it's lower, so if it's kind of at the bottom, we call it a relative minimum. And these points become very important for some of the things that we're going to do later on. So there's kind of two different ways to find these, and we're going to use the calculator for this. There's one way in the calculator that will give you the absolute exact number for the point, but it's a little complicated, and I'm going to show you a way to use the trace button, and it's going to get really close, which means when I write my answer down, it may be a little bit different than what you have on your calculator, because we're not going to get that exact number. So let's type in this equation, this cubic polynomial. So we have x cubed minus 6x squared plus 7x plus 2. So type that in and then hit graph. And then I'm just going to sketch this shape out over here. And we have two turning points. Right here is one. Would that be a relative maximum or a relative minimum? Do you think? Maximum, because it's kind of at the top of that peak. And then this one would be the relative minimum. There is also something called an absolute max and min, meaning if there was an absolute maximum, there would not be any other points on the whole graph that's higher than that. This graph does not have an absolute maximum because it keeps going up forever, so there's no way I can actually find the highest point. Same for the lowest point. But these that are at the tops of the hills and valleys, we call relative max and mins. And I'll probably get to where I'm not using the word relative. I'll just say the max, the min, and you know that's what I'm talking about. So on your calculator, click the trace button, and that lets you trace along the graph. So use your left and right arrow. So if we start at the very left to where the blinking cursor is kind of down here, and I'm going to move right. My dot is going up, 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 up until it reaches the top of the hill. And so we want to find where my y value is the highest. So if I kind of move left and right a little bit, the biggest y value for me is this 4.294. Yours might be a little bit different, but it should be close. So I'm going to write out this point, and I want you to go to 3 decimal places, rounding to 3 decimal places. So the maximum would be roughly 0.758 for me. Yours might be different. Put what's on your calculator. And then mine has 4.294. Yours should be close, but won't be exact. And then if I keep arrowing over till I get to this valley, I want the lowest y value, which is 3.333 for me, and negative 4.296. Does anybody need help getting these 2 points? So we've got some examples to do, just 4 examples. So number 9, go to your y equals and type in this equation. Now I want you to just real small sketch the shape of the graph. And I want you to mark the points and put max or min beside of them. So these two, because they're at the top of the hill, they would both be a max. And then this one would be a minimum because it's down in the valley. We hit the trace button. Now I would always like you to start on the left. Because when we get to something for increasing, decreasing, we work left to right. So if you get in the habit of always starting on the left, that would be good. And then we arrow to this maximum. So for the first max, I get on my calculator negative 1.515 and 5.943. And then as I keep going, I get to a minimum. You should get about 0.303, comma, negative 1.247, something like that. And then back up to the maximum. .212 and 0.294. Number 10. Any questions on number 9? All right, so let's move on to number 10. Go to your y equals and type in this equation. We have one max and one min. So at the trace button, go up here to this max. We have negative 1.9. That really is going to round up to 970. and 6.996. If I were to look at the table for this, it probably is -27. It's probably the actual point, but we're just going to put what the closest that the calculator gives us using the trace button. And then the minimum, -0.606, -2.467. Questions? All right, if you've not done so, go ahead and finish numbers 11 and 12. Number 11, your max should be roughly 1.970, comma 3.997. And your minimum was 0, 0. Max on number 12, you had a 0, 4. That should be your minimum down here. Oops. And then you had two minimums at -1.667, comma -1.245. And then another minimum at 0.909, comma 2.955. And again, your numbers will be off a little bit. So on a test, it may be like multiple choice, and you'll know, find the closest one. This is one of very few times when you just pick the answer that's closest to the one you get. Most of the time, that's not the correct way to go. Any questions?
It's all right if it is exactly on point, though, right?
With what I've got?
Yeah.
Yeah. Sometimes it will be, maybe. Sometimes it won't be. Any other questions? All right.